Hello friends, welcome you research units. In this video we will see Y maze and radial maze, a small protocol for both, and we will see about the terminology used in Y maze and radial maze and their explanation. So we will go ahead and see. So what is Y maze? In instrument descriptions, Y maze is a behavioral apparatus used to assess spatial memory. Spatial memory means it is related to place, working memory, and learning and exploratory behaviors in rodents. Exploratory behaviors means new place, explore the new area. So structurally it is a Y shape, and in each arm between it has 120 ounce angle, and each arm is usually its measurement is 30 to 40 centimeter long each arm, and 5 to 10 centimeter wide, and 15 to 20 centimeter height. Arms are labeled as A, B and C. Like here you can see A, B and C. It is made up of wood, acrylic or PVC. The maze is placed in quiet and controlled environment with minimal external cues. So you have to conduct the experiment in the separate area. So Y maze, what parameters we are studied? Spontaneous alteration behaviors, novel arm explorations and short-term memories. This all terminology we will see in detail later in this video. So now we will go ahead. We will see the radial arm maze, instrument descriptions. Radial arm maze, RAM, is more complex spatial memory tool used to evaluate long-term memory, learning and decision making. So it is complex than the Y maze, so the rodent have to decide where they have to go. So it is useful tool that the animal has some decision making capability or not, that we can evaluate by using this instrument. So consists of 8 to 12 arms radiating from the central circle hub like spokes of a wheel. So we are placing the animals at the hub in center, and it is moving from there in all the arms. So its measurement is 40 to 50 centimeter long, 10 centimeter wide and 20 centimeter height. Food wells or food pellets may be placed at the end of the arm for reward based task. Can be elevated or placed on the ground. So this maze we can use both place. We can place it on the ground or elevate it. So what parameters are studied? Working memory errors, reference memory errors, learning index, arm entry sequence. So these parameters we will see in detail later in this video. So what is the protocol generally used for Y maze and radial maze? So we will see this flowchart protocol, Y maze. So first, to start the experiment, animals are acclimatized for 5 days. Then you have to clean the Y maze with 70% ethanol. You have to place the animals at the arm A to start the experiment. You have to allow free exploration for 8 minutes. In meantime, you have to record arm entry sequence, number of alterations, time spent in each arms, and novel arm preference. Then later you have to remove the animals after completion of the 8 minutes, clean the maze for next trial, calculate spontaneous alteration percentage and working memory index, that we will see later in this video, interpret memory performance. So this was the protocol for the Y maze. Now we will see the radial maze protocol. So first of all, you have to keep the animals 5 days acclimatizations in the same room where you have placed the radial maze where you are going to conduct the experiment. Clean radial arm maze, place animals at the center hub. Training phase. Here in Y maze there is no training phase if protocol not permit, but in radial maze you have to conduct training phase and then test phase. First training phase, bait selected arms, optional. Bait selected arms means where you have placed the reward or food. Allow exploration for 50 minutes. And test phase, allow exploration again. Generally it is same times, training phase and test phase. Sometimes it is less, 10 minutes. So then during this experiment is around for 15 minutes you will record arm entry pattern, correct versus incorrect entries, working and reference memory errors. So what are these terminologies? We will see in explanation later in this video. Then we will remove the animals and clean the maze after trial. Calculate memory performance index. So this was the protocol for the radial maze. Now we will go ahead. We see all the terminology that we have seen till now in this video. So arm entry pattern or sequence. So this refers to the sequence in which the animal enters in different arm during explorations. So why it matters? Shows exploratory behavior, help analyze strategy, random or organized. A structural pattern suggests good learning ability. So examples, YMS sequence is A, B, C, B, A, like that. In RAM sequence, 1, 4, 6, 8, 2, 3. So this is arm entry pattern. We will see other parameters, then we will easily understand these parameters. So now we will go number of alterations. These parameters generally we are studying in Y maze. So an alteration occurs when the animals enters 3 different arms consecutively. Examples, arm entries A, B, C, A, C, B. So alteration A, B, C 1, B, C, A 2, C, A, B 3 and A, C, B 4. So these are the maximum number of alterations. So 4 alterations we can calculate, means generally we can get. So each set 3 consecutive unique arms, 1 alterations. We are counting if it is visiting CAC, so it is not alteration. If it is visiting CAB, then it is a 1 alteration we have to count. So like that, all the possible alteration you have to record as per the animal's positions, what alteration it is producing. So purpose, measure the working memory, because the animal must remember the arm visited previously, so it is generally not visit that place. So number of alterations. What is the importance of number of alterations? Animal prefer to visit new area, novel area. So time spent in each arms. This is the total duration the animal stay inside the each arms. Why it is necessary? Indicates preference, anxiety and learning. More time in the novel arm, better recognition memory. And more time in familiar arms, poor memory or anxiety. Animal has anxiety. So next parameter is correct versus incorrect arm entries, radial arm maze. Generally these parameters we are using radial maze. So correct entry, working memory correct. Entering a new arms that has not been visited in the correct session. So it is correct entry. Incorrect entry, there are 2 types, working memory errors. Re-entry, an arm that has already visited during the same sessions. Reference memory error, entering an arm that is never baited, food is never placed. So there are 2 types of incorrect entries. So that you have to record during the radial maze. So spontaneous alteration, percentage Y maze. Generally this parameter is very important for Y maze. Formula: spontaneous alteration percentage, spontaneous alterations divided by, means the animal has done the spontaneous alteration, that you have to record, and total number of arm entries minus 2 into 100. So here total number of arm entries means maximum possible alterations. So total entries, maximum possible alterations, what can be in Y maze, that you have to add here. So in the formula, total number of entries, so maximum possible alterations means, suppose it is A, B, C, so it's one alterations. So what is the maximum possible alteration, that you have to write, you have to count and write. It's generally 4 minus 2. So spontaneous alteration, when the animal enters all 3 arms sequentially without repeating an arms, spontaneous alterations. So example of correct alteration: A, B, C or C, A, B. So here we are not repeating, the animal is not repeating the same arm again. Rodents naturally explore new areas. High alterations is better short-term memory. So this is the importance. So interpretations: high percentage, more than 65%, good spatial working memory. Low percentage, than the 50%, memory impairment. So now we will see next parameter, normal arm preference, Y maze, 2 trial task. So in that earlier we have seen the Y maze for 1 trials, no need of training phase, but here you have to do 2 trial. So animals are explored 2 arms initially, sample phase, and third arm, novel arm, is open during the test phase. So first you have to trial the animals closing the one arm. Novel arm preference, more time plus first entry into the novel arm equal to intact recognition memory. Meaning, if animals quickly enters and spends more time in the new arms, it remembers the old arms. Failure to prefer the novel arm, impaired memory. So we will see the next parameter, working memory index, Y maze or radial maze. So this index quantify how efficiently the animal avoids revisit previously entered arms. For Y maze, high spontaneous alteration percentage equal to high working memory index. For radial maze, working memory index, correct entries divided by correct entries plus incorrect entries, all you have to calculate into 100. So you can easily calculate working memory index, where correct entries new arms, incorrect repeated arms. Interpretation: high working memory index close to 100, strong short-term working memory. Low working memory index, poor working memory, many repeated arm entries. So how you can calculate working memory? Suppose it is for radial arm maze. Example, if an animal makes 6 new entries and 2 repeated arm entries. So what is the working memory index? 6 divided by 6 plus 2 into 100, 75%. So this is how you can calculate working memory index. So in some protocols reported Y maze and radial maze working memory index combined, how to calculate that we can see, or by error how we can calculate working memory index. So working memory index error equal to re-entry into arm already visited in the same trials. So it may be for Y maze also, and For radial working memory error equal to number of re-entries into previously visited arms. That we can express in percentage working memory index percentage re-entries divided by total arm entries into 100. So this is formula by which you can calculate working memory error percentage. RAM means radial arm reference memory index. In previously you have seen how to calculate reference memory index. So reference memory equal to entry into arm that never contained rewards or bait or food. Reference memory error RME entries equal to into never baited arms. Working memory index combined YMAs and RAM. How we can calculate working memory index by error? Here you can see it is same than the earlier parameters. Here you can see working memory index for YMAs and RAM for radial arm maze. It is calculated by the entries, but it is calculated by entries by errors, and combined you can calculate both. Working memory index equal to 100 minus working memory errors percentage. So this is how you can calculate here working memory index using errors in both radial maze and Y maze. So now last terminology we will see for radial arm maze. Based on error decreasing over days, learning index, performance on last day divided by performance on first day into 100. So here at the place of performance you can put number of correct entries, number of errors, latency, working memory index. So these are the terminology we have explained here for radial maze and Y maze. So how was the video? Please do comment. Thank you for watching Research Need. Thank you very much.